This is the next section in Chapter 10, 10.4 Experimental Design, which is designing experiments. How can you use an experiment to test a conjecture? So again, most of the material this week is conceptual and not too much computing to be done. So read up, read carefully, and if you need to use a dictionary, make sure you do so. That's a number one tool in reading. In a controlled experiment, two groups are studied under identical conditions with the exception of one variable. One variable means that there's one thing different about them. So for instance, if I wanted to test this new drug for a medical condition, then you would want to test people under identical conditions with the exception of one variable. So you want to make sure, if possible, those people are as similar to each other as possible, or when there is variety, that there's an equal amount of variety. And I'll go into a deeper description after I've covered some other vocab. The group under ordinary conditions that is subjected to no treatment is the control group. The group that is subjected to the treatment is the treatment group. So when you have a controlled experiment, you have two groups, one that has stuff done on them, and then which is the treatment group, and then one that's kind of like nothing happens, the control group. Randomization is a process of randomly assigning subjects to different treatment groups. So, last week or 2 weeks ago, I can't remember, we went through selection methods. Randomization is ideal because you don't want your bias to cloud anything. So when you're, for instance, if you're experimenting with that drug, depending on what the drug is, you might look at someone's appearance or someone's medical chart and be like, if the drug looks like it will work better on this person, then you might be incentivized to put that person in the treatment group so that the drug ends up looking better. But if you randomize it, then you have a more accurate sense of is my drug or is my treatment, whatever the treatment is it working? And treatment, it's a pretty broad term. I've been referring to drugs, but a treatment might be does this diet plan work? So the treatment is it could be a diet plan. Or, does this fitness plan work? The treatment could be one group works out. Or so the treatment could be one group works out and the control is they don't work out or they stick to the regular routine or whatever. In a randomized comparative experiment, so we got random, or people are randomly assigned. Comparative, you're comparing one thing to another. Experiment, an experiment that you run. Subjects are randomly assigned to the control group or the treatment group. In some cases, subjects in the control group are given a placebo, which is a harmless, unmedicated treatment that resembles the actual treatment. So, for instance, if we were testing Tylenol for pain medication, then you could randomly assign people one group to treatment, one group to control. One group gets Tylenol, and then the other group gets a pill of sugar that they don't know is or something else that's not Tylenol and has no effects, so that you are rigorously actually testing the drug and not some mental effect, right? Like people being hyped by taking a drug even though there might not be anything in it, literally. Determine whether each study is a randomized comparative experiment. So we've got to see two parts. Is it random, and are we comparing stuff? If it is, describe the treatment group, and the control group. Vitamin C lowers cholesterol. At a health clinic, patients were given the choice of whether to take a dietary supplement of 500 milligrams of vitamin C each day. 50 patients who took the supplement were monitored for 1 year, as were 50 patients who did not take the supplement. At the end of 1 year, patients who took the supplement had 15% lower cholesterol levels than patients in the other group. So people get to choose whether they take this vitamin C. So is that random? How convenient. Solution. The study is not a randomized comparative experiment. Is it random? Well, if they get to pick, then that's not random. Someone has to be assigning them. Because why might that be not random? Well, people who are choosing to take it might have more interest. They might just make better decisions, better health decisions for themselves. Like, oh, who's more likely to volunteer to take a vitamin? Someone who cares about their health or someone who doesn't care about their health? Right? Like, oh, someone who cares about their health. So then you that might impact the study in that, like, oh, well, you can't say it's the drug doing it. Maybe it's this person who cares more overall and so does other things as well outside of that drug. Supermarket checkout. Checkout even faster. To test the new design of its self-checkout, a grocer gathered 142 customers and randomly divided them into two groups. Okay, they randomly divided it, so that's that part. Randomized. Now let's see if it's comparing. One group used the new self-checkout, and one group used the old self-checkout to buy the same groceries. That's important. If you're buying different groceries, right? Like if one person uses one self-checkout, but they have like one item, and the other person has 15 items, does that have anything to do with the actual checkout? No, that is like the number of groceries they have is impacting it. Users of the new self-checkout were able to complete their purchases 16% faster. So they're randomly assigned, and then you're comparing. So, yep. It is a randomized comparative experiment. Randomization in experiments and observational studies. In an experiment, individuals are assigned at random to the treatment group or the control group. In an observational study, so an experiment is when something is happening by design. Like you, the researcher, are implementing, these people are going to eat Tylenol. Versus an observational study is, you're just watching something happening and you're taking like careful notes. Observational study, when possible, random samples can be selected for the groups being studied. So when you're looking at something, or when you're trying to study something, you don't have to look at a whole population, but you do have to look at random samples. So when you're picking the people to observe, if there's like 10,000 people in the population, you can't observe them all. You want to randomly pick the people that you do interview to get a good idea of what the overall picture is, and not just looking at like one subgroup in particular. Good experiments and observational studies are designed to compare data from two or more groups and to show any relationship between variables. Only a well-designed experiment, however, can determine a cause and effect relationship. So if you're doing an observational study, then you can't determine cause and effect because you're just looking at what's happening. Like you're not sure if there's other things, other factors or variables that are impacting the outcome. But for a well-designed experiment, it's like, well, if it's well-designed, that means there's only one thing different that you are like putting on them, and then these other factors are not going to be a big deal because you've designed the experiment well. A rigorous randomized comparative experiment by eliminating sources of variation. Eliminating sources of variation is like other factors. Other than the controlled variable can make valid cause and effect conclusions possible. An observational study can identify correlation, but not causality. So there's a relationship, but it's not necessarily, one thing is definitely impacting this other thing or making this other thing happen. Variables other than what is being measured may be affecting the results. Explain whether the following research topic is best investigated through an experiment or an observational study. Then describe the design of the experiment or observational study. You want to know whether vigorous exercise in older people results in longer life. The treatment, vigorous exercise, is not possible for those people who are already unhealthy, so it is not ethical to assign individuals to a control or treatment group. So when it's not ethical, like you can't do it just because you came up with it, right? And since there's people who are already unhealthy that are old, that can't do the exercises, then it's not fair because like you're automatically excluding them. How is that fair, right? Like, what are you just going to ignore this population? So instead, what you're going to do is you're going to use an observational study. Randomly choose one group of individuals who already exercise vigorously. Then randomly choose one group of individuals who do not exercise vigorously. Monitor the ages at regular intervals. Note that because you're using observational study, you should be able to identify a correlation between vigorous exercise in older people and longevity, but not causality. So you should be able to see, like, if this is correct, like that vigorous exercise, like vigorous means like good exercise, like hard exercise, in older people results in longer life, then as you're tracking them, what does it say? Monitor the ages of the individuals at regular intervals. This means you're not looking at it like over the span of like a month. It says regular intervals, and you want to know. Oh, as these people get, you want to know about their longer life. That's not going to be on a span of like months, right? So you're going to be monitoring their age and their exercise level through years, and you should be able to see if it's correct that, oh yeah, like these people who exercise a lot, like they're living longer. Or if not, then you won't see that pattern. But either way, whichever pattern you see, you don't get to officially declare, oh yeah, it has to be the exercise. Like, well, you don't know that because you're not the one assigning them to exercise or not. It could be other factors in their life, like how wealthy they are, or the number of family members that they see regularly, or something like that. So here's some more. And then the last vocab word is replication. So let's go to this. An important part of experimental design is sample size, or the number of subjects in the experiment. And why is this important? Do you want more data in your sample, or do you want less data? And why? To improve the validity of the experiment, replication is required, which is repetition of the experiment under the same or similar conditions. So you have to be able to do something over and over again. Like, you can't administer a drug in like San Jose, and then somewhere in Oklahoma runs the experiment and is like, oh yeah, it turns out this drug is not effective. Like, well, if it doesn't work in Oklahoma and San Jose, like, then you can't really say that it works, right? It might be something. It might be the water in California, or it might be the sunshine, or it might be something else that's not the experiment that you are trying to run. So you do have to be able to replicate something which is doing the exact same or at least very similar conditions. Let's do a quick analysis, I guess. A pharmaceutical company wants to test the effectiveness of a new chewing gum designed to help people lose weight. Identify a potential problem, if any, with each experimental design. Then describe how you can improve it. Let's just look at the first one. The company identifies 10 people who are overweight. 5 subjects are given the new chewing gum, and the other 5 are given a placebo. After 3 months, each subject is evaluated, and it is determined that the 5 subjects who have been using the new chewing gum have lost weight. Well, you want to know if it's going to work on a lot of people, and you've only tried 10. So, like, that, like, right? Like, that doesn't make any sense. We want big sample sizes. So for this case, we would want a bigger sample size. Here are 2 more examples. Read through it, and then obviously, like, solutions right there if you're not sure. But yeah, and then let me know if you have any questions. But that is experimental design. Make sure you go through the vocab pretty carefully, and then let me know if you have any questions.